Here, bringing forward this. I'll be moderating this last talk today. The talk will be delivered by Ashok Rathinam, and the talk is going to be on optimization. So he's going to be talking about optimization in real-life business problems, specifically in the supply chain domain, right? Um, the only thing, it's a Friday. We've had a lot of sessions, so the only thing that I can tell at the end of a Friday to keep you hooked to your seats is that Ashok is going to be talking about very contemporary problems in supply chain that can be solved using data science, which are very ripe, right, and waiting to be solved. Because as you know, in supply chain optimization, right. Optimizing production planning is as old as the woods, but he has been there, he's seen it, he's done it, he knows what the problems are today, right, waiting to be solved. And he also discusses another very hot problem, which is the Uber problem, which is something that should interest a lot of startup enthusiasts. So I'll introduce Ashok. Ashok is a supply chain solution specialist. He's had work experience of almost 2 decades. He's been with Thoucentric for 4 years. He leads the supply chain solutions practice in Thoucentric. He's worked with the Ericssons and the SAP of the world, and then he's consulted with the Unilever, Cargill, DHL, Diageo, you name it. He's been everywhere. So that's about Ashok. Ashok, over to you.
Thank you, Sailesh. I'll just take a moment to share my screen. Please let me know when you can see my screen. Is the screen visible to all of you?
Not yet, Ashok.
Not yet, Ashok.
So take your time. Maybe it's a network thing. It's visible now, Ashok.
Okay, perfect. Thank you all for joining this session on a Friday evening after such heavy and deep topics, though very balanced, of course. And I think Sid and team had a very strategic reason to keep it at the end of the day, just to keep it a little light, conversational, maybe talk about business applications rather than the technology or the algorithm itself. Okay, so let me get started. Before I start, I'd like to first congratulate and thank the our analytics practice and SIDS team for hosting 2 such wonderful days of simple, informative, and very educational sessions with such insightful panel discussions as well. And I'm definitely confident there was something for everyone, for analytics beginners like me to experts, some experts who are already with us on these sessions. So thank you and well done, team. And I'd also like to thank them for giving me this opportunity to talk a little bit about applications at the intersection of data science and traditional optimization. And before I start, I'd like to set the expectations right for this session. So first I'll talk about what this session is not about. This is not about how to do mathematical modeling for complex optimization problems. This is not even about what approach to take for optimization. And if you want a masterclass on any of that, all you have to do is just follow our in-house analytic expert, Dr. Anasuya Ghosh on LinkedIn. She's been publishing quite a few interesting articles on optimization over the past few weeks. And so this session would be more about business applications on the evolution of prescriptive solution itself, and how we can kind of leverage the advancements and the ubiquitous options available to improve the quality of my supply chain optimization results, right? And I had a what I thought a cooler topic. It was kind of shut down by the quality process for this conference. I have it hidden somewhere in one of these slides. Let's see if you can spot them. And moving on with a couple of very good fundamental callouts to say great wisdom or great insights from data. If it's not applied to action and behavior, it's not really meaningful, at least for an operations person like me, right? So of course, outside the scope of operations from research or from customer behavior study, there could still be many applications. But for an operations person, as long as it doesn't help me with actionable insights that I can use on the shop floor, that I can use in my warehouse or transportation, it's not really useful because it's not helping me improve my KPIs or business outcomes, right? Having said that, what does a supply chain practitioner really want? So let's first see where a typical supply chain practitioner is today. So all facilities, all infrastructure have been tapped to the maximum. They are already operating at peak capacity, but still have their bonuses stacked to annual efficiency improvements, right? How do you improve efficiency of a manufacturing line beyond 95%? Theoretical maximum of 100% does not apply to operations. So what do I do? How do I extract more out of my existing infrastructure and ecosystem and technology investments? So one definite possibility is to look at leveraging data science to understand how events will unfold within my planning horizon, right? And within my planning intervals. Whatever advanced optimization I do, I'm not going to be doing it every hour. I'm not going to be doing it every day. Even the most advanced supply chains run your scheduling algorithms or optimization algorithm once in a week or sometimes even once in a month. How do I factor for all those real events and drivers of those events that are happening on a real-time basis, right? So as a production planner or as a shop floor operator who owns the manufacturing, I cannot rely on an outcome that comes once in a month, right? I need to make real-time adjustments, and that's one of the primary drivers of efficiency loss, manual interventions to a so-called optimized plan, right? So what can be done about this is to leverage a technology or a platform that can help the operations guy understand how events will unfold or what can trigger a need for a change in the plan, right? And what should they do? First is to see what events can happen, and based on those combination of events, what is the action that an operations manager is supposed to do, right? So only these two things can really help a planner take efficiency to the next level, right? We are talking about quantum improvements, not incremental improvements, right? So we definitely think there is a significant opportunity there, right? Now, before we go into further slides, I'd like to focus a little bit on the prescriptive piece itself. So what do we mean by prescriptions? A prescription is a recommendation, right? So though it could be the highest level of maturity in analytics, at least from supply chain planning perspective, we have been living with prescriptions all along. So every plan that I generate, either from an 8-column notebook or an Excel or the most advanced algorithm running in Amazon Cloud, gives me what is called a plan, right? And plan is nothing but a prescription for my operational community, right? So what is that is new? Why are we talking about prescriptive analytics as about something of the future? There is a difference, though every plan is a prescription. The evolutionary prescriptive analytics that we are talking about, or what we call it as the final frontier, is the intelligence that is baked into the prescription, right? So even an Excel sheet can do a simple demand minus opening stock plus production plan as the expected output, but there's no intelligence there, right? So today a lot of time is spent on reviewing the prescriptions coming out of systems. How can I minimize that? How can I inbuild intelligence into my prescriptions, right? That's what we're talking about. So let's move on to the next slide. Okay, here maybe we can talk a little bit about the concept of optimization itself. Having said I'm not an expert in building optimization algorithms, I've used quite a bit of um, those solvers and solutions to solve supply chain problems, right from supply network optimization to network design to last mile delivery optimization. Right now, about the concept of optimum itself, and I'd also like to quote one of my what I think is my insightful observations. Most insightful observations are around optimization, centered around the word optimum itself. Right, and optimum, it's such a beautiful word, represents the perfect balance, or the just the right quantity, or just the right level to be at, right? So if you look at the word itself, it's a perfectly balanced 7-letter word centered around the word I, right? I could be each of us as individuals. I don't know if anyone had this in mind, or it's coincidental, but it's such a beautiful coincidence that such an excellent word that represents all that we should do right to get the best business outcome is itself balanced so much. So another uh, 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 a word that has a similar balance is equilibrium. So another beautiful word. Maybe these are things you can wonder over the weekend, and we continue with the session. So again, optimum itself. Okay, so we can talk about an optimal level, or an optimal point, or an optimal quantity. Each of them represent the best state that a system can achieve, right? Optimal point is the best state that it needs to achieve and stay, right? Or be at equilibrium at that point, right? That would be an objective for anyone performing a complex system design, especially for operations that needs to run a million times over a period, right? And optimal quantity, again, beautiful, just the right amount, nothing more, nothing less, to require this to achieve the specific business outcome. And at the bottom of the slide, you'd probably see the title I actually wanted to have for the session. So marrying predictive and prescriptive, a perspective. It's cool, right? I didn't get to keep it, but still managed to use it. So let's move on to the real core of the discussion today. Okay, this is such a beautiful, simple, and such a lovely demonstration of the evolution of analytics itself, especially for supply chain. We started with business intelligence or even Excel dashboards, which are basically going to tell me what happened last night, what was the result of my MRP run, right? To basically look at what happened, right, and see if there were any exceptions that need focus. And then we moved on to diagnostic analytics, where we are talking about understanding why something happened that actually happened, right? So if we can build some intelligence into that through data science and segmentation techniques, nothing like that, but even traditionally we were able to do some diagnostic analytics through so-called loss trees, or automated root cause analysis and stuff like that. A lot of it has become quite feasible, and multi-level drill downs pointing to an actual cause of an exception is possible today with all the advanced analytics algorithms. And again, even at a diagnostic level, I am still doing a reactive analysis of something that has already happened before, right? Now that again is post-mortem, and it's going to help me prevent it from happening in the future, but again it has already happened. But if the quantum of the damage was big, there is no um, we also have to live with the damage. Right now, what could be the next level is predictive analytics, to say what will happen, and that's where the basic concept of forecasting comes into the picture. And again, We have quite a few advancements in forecasting process itself, which we'll talk about in a bit. And the last one, like we talked about, is intelligent prescriptions, right? Prescription that does not review a scrutiny at a line item level by a human, right? That's what we are talking about, the final frontier of optimization. It is not just churning out a plan, but churning out a reliable plan that does not need review or intervention by a human, right? So that's probably the holy grail of analytics for supply chain, at least. Now, if we move on to the next slide. Um, we are talking about what are the different opportunities for optimization in different operational areas. But before I move into that, I'd like to dwell a little bit on the most predictive input that is relevant for any business, especially supply chains, right? So all of us know what it is. It is forecast, right? Your business forecast, business projections, customer demand. They are called in different names, but the most important input to any planning process is my business forecast, right? And irrespective of what my algorithm is, without touching the algorithm with a 10-foot pole, if I can improve the quality of my forecast, right, through any technique, right, even by just choosing the right statistical algorithm, even by choosing the right moving average in number of periods, if I can improve my forecast incrementally, that little bit, that can directly help me reduce the error in my plans or the need for manual interventions or changes to my plans, right? So before we get into all other areas where I can leverage predictive, I want to spend probably 30 seconds on this slide where we talk about what predictive intelligence and the latest technologies and platforms are offering us in terms of improving the quality of my business forecast itself. So again, Gaurav and Sid talked about this in today's and yesterday's sessions quite a bit. We are again talking about advanced demand forecasting algorithms that don't only rely on your historical sales. They are not only looking back in time, but forward looking in terms of what's going to happen in the future. And an algorithm like this, like we also discussed in our panel discussions, is probably going to go mainstream in the next 6 to 12 months, because especially in the post-pandemic environment, a lot of your historical data may not be directly useful for extrapolation, because the world as we know it, especially for certain segments or products or services, has changed significantly. The consumer behavior has changed significantly. Therefore, the driver of sales would also be quite different, right? So it's no longer sufficient to rely on your historical data. You may be a traditional consumer focused company with 50 years of history, but still that's not going to help you achieve the same level of forecast accuracy that you were able to achieve 2 months ago, right? So every business would have to look at incorporating some kind of environmental drivers, right? It could be the disposable income that is in the hands of the people today, that has changed significantly, and what is the distance that people are able to travel, what are the kind of dynamic restrictions that are going to come in play, is there going to be another wave of infection, all that, right? So considering the environmental drivers or the external drivers influencing your sales is going to be very, very important to achieve an operational level of forecast accuracy, right? And that's where all these concepts and factors and drivers that are captured in this slide come into play. So we need to consider a data lake or some kind of a big data environment that's capturing all these data in their true volumes, and again we need to capture the customer behavior drivers itself, right? That again from social media or I can take any proxy for customer behavior. Identifying that proxy itself is a major exercise, so that is an investment that will definitely pay out. And both these come together along with your historical data, of course, and then to give you a more accurate, more granular and more reliable forecast. right? It's not going to be as easy as we are talking about. It's an incremental, iterative, and participative process that we work very closely with the business. But even prior to the current situation, we have been able to provide demand sensing or advanced forecasting solutions that could help businesses achieve a 10 to 15% improvement in accuracy over already mature traditional forecasting models. So, so if it can perform so well in that environment, we are definitely sure it will be able to get even more improvements in accuracy, considering where we are today and the need to leverage all these drivers, right? So again, the primary input for any planning, the predictive input as forecast, every organization will take a shot at leveraging data beyond the historical data, and that is something we really look forward to, and we are really confident of helping our existing and potential clients in this space. Now, going back to the other operational areas where we are really attempting to optimize different operations, or we are trying to optimize our landed costs, operational costs, customer service costs, and all this while trying to maximize the customer service, right? We are in the era of Amazon, where nothing less than a delightful experience works for every customer. Therefore, optimizing customer service is, of course, at the forefront of every optimization problem. Now, if we look at each of these cases, we can even spend 10 minutes on each of these, talking about what are we trying to optimize, but let's try to keep it at a 15 to 20-second discussion on the optimization opportunities in fleet and transport management. Depending on which side of the spectrum you fall in, if you are a shipper or a service provider, you are trying to optimize for different things. The common element being cost and customer service, right? Both of us are trying to optimize for cost. Both of us are trying to optimize for customer service. For the logistics service provider, the shipper himself is the customer, right? But all of us are looking at the eventual customer experience, who's going to consume my products or services, right? So here we need to optimize for around the constraints, optimize for cost, service level, fleet availability, warehouse working hours, incompatibilities. So we have a very good use case on this. We can spend a little more time on that later. Coming back to warehousing, we are trying to optimize for labor. We are trying to optimize for turnaround time. We are trying to optimize for truck arrival and departure, right? We are trying to optimize for pick phase versus bulk storage, right? We are trying to optimize for the space that I need to pay, the rent that I'm paying, right? All that. And order fulfillment, again, I'm trying to optimize for making my priority customers happy, trying to make sure my business efficiency issues do not affect my customers' businesses, and trying to optimize for that, trying to optimize, of course, for the cost of service of last mile delivery, right? And multiple other constraints. Stock replenishment or internal movements, again, we are trying to optimize for bulk movements. I'm trying to keep my pipeline stocks and cycle stocks as minimum, and optimize my transportation lead time as well, exploring different mechanisms that are possible, different kind of services that are being offered, what a Rivigo offers versus what a traditional fleet operator offers. Both have its own pros and cons, and quite a few options available to optimize my intercity long hauls or internal movements, right? And procurement itself, I'm trying to optimize for my landed cost. We are trying to optimize for the inventory that I need to keep for every product. I'm trying to optimize for the reliability that I'm expecting from my vendor. So we are trying to optimize different variables for each of these processes, and the optimization process itself is quite mature, right? So there are algorithms available that can process millions of records, process thousands of orders. Even organizations like Apple, which get probably 1 million orders on the first day of a new product launch, are running on enterprise solutions, large enterprise, traditional enterprise solutions, along with their of course, in-house enhancements, of course, but the backbone are still is a traditional enterprise solution, and they're able to optimize and handle it. So it's not that our traditional technologies are not able to support it. The point is, how can I take it to the next level, right? So let's look at a couple of cases. First, let's talk about a very, very traditional planning process, which is my production planning, right? So production planning, like Sailesh mentioned appropriately, is as old as the woods itself. If I have to manufacture something, I have to plan for it, because in manufacturing, I have to put n number of things together, make something out of it, add value on top of that. It may be painting, it may be finishing, it may be just applying a sticker, and then packing it and putting it to the warehouse for dispatch, right? So a lot of things need to come together. Your labor capacities, your machine capacities, your material availabilities, optimization of infrastructure, and all that, right? So this has been a historical process, and quite a few organizations are extremely mature in their planning process. So why do we need another layer of technology to kind of further complicate it, right? So very, very valid question, but let's look at the real situation on the ground, what's happening. Even the best and most mature supply chains still have manual changes to their production plans. Now, why those changes are being made? There are some genuine reasons, and no technology or platform or algorithm can replace human intelligence, like we have been hearing from all our fellow analytics colleagues. So there will be, of course, that certain small percentage of plan changes that only a human intelligence can perform, right? So now accounting for that, right? Even accounting for that, there is still a significant space to improve the quality of production plan. So hypothetically, let me say, in the most mature of organizations, there is a 5 to 7% manual intervention that is inevitable, right? But what is the reality? So what is the percentage of changes that are being made to production plans today? So unsurprisingly, during our study, we found out the level of manual intervention was something ranging from 60 to 20%, right? So there is so much of manual interventions being made, right? So some of them, or there could be cases of technology adoption itself. If they had adopted and enhanced the existing technology to suit their requirements, maybe the manual intervention would have come down. But even in factories or supply chains which have managed to adopt and utilize the technology effectively, there is still a 10 to 20% of manual changes that are being made, right? Now we just try to break down the potential reasons and probably cluster them together to say what could be the major drivers of changes to my production plans, right? The first is the change in the forecast itself, which we discussed in detail in the previous slide. So if my basic input, which is my forecast or a customer demand, changes, my production plan, of course, will change. And the bigger problem is not the change in forecast itself, but the change in the forecast within the frozen period, right? Or the operational period within which ideally a factory or a warehouse would not want to change the plans. They have already planned for a certain capacity. They have already made a plan for operational plans for the next few days. But if today's demand or tomorrow's demand changes, there is no option but to change my production plan, right? So how that can be accounted for, we discussed in the previous slide. I have a advanced analytics engine that's able to leverage and probably identify what is causing this plan, right? And we plug it over a period of time, and the contribution of the forecast change to manual intervention should come down over a period of time, right? Now, what could be the other big drivers, right? So again, like we said, improvement in forecast quality is an ongoing initiative in almost every organization. Every demand planner, every technologist is probably working on that problem, and of course they will bring it under control, right? Now, what are the other things that have been hiding in plain sight, right? So what are the things that we have taken for granted over a period of time that could help me improve my production plans. So in a single word, it is called master data, right? A lot of things, lot of parameters under the category of master data have been approximations, have been static values, right? And there was also a genuine reason for that, considering that all these technology platforms were developed 50 years ago. We did not have today's computing capability to accommodate dynamic master data, or I wouldn't use the word master then, it's dynamic inputs, right? So manually it was impossible for a planner. Let's take a simple example of let's say machine capacity, right? Today what happens in every planning solution, I use an approximation of the capacity, and on top of that I might put something called a yield factor or a utilization factor to further reduce the capacity that's actually available for planning. This needs to be done, of course, because not every machine works at a rated capacity level, but who decides what the number should be? So it could be an annual approximation. Even in the most data-based decision making, they are probably using historical averages, right? And last year's average might not apply to this year because I might be producing a different set of products. My product mix could be different. My downstream machines could have changed. My operational automation could have improved. There are quite a few things that could make today's available capacity specific. And looking at another dimension, I cannot standardize capacity availability across all the products or all the units that are going to be produced in the same machine, right? It will depend quite a bit on, it will be a function of the product I'm producing, the size, the batch size that I'm producing, of course, the operator who is kind of operating that machine, right? The time of the day that I'm using it, and the time from the last annual maintenance, right? The day right after the annual maintenance, the machine is going to be all spick and span, right? So its capacity is probably going to be at high 90s on that day. But as I keep using it, wear and tear of different components can cause the available capacity being reduced, right? And maybe closer to the next maintenance cycle, I've come down to my high 80s. But there is no traditional planning system that can account for all this, right? So even if this option was made available in the technology, and they asked someone like me who started as a planner to maintain the capacity, available capacity for different combinations of manufacturing SKUs and the operational parameters, right? So it would have been impossible for a human to maintain 700 possible values of capacity for a particular machine, right? But that's the reality. A machine operates realistically probably with this 700 capacity levels, depending on what I'm trying to produce, when I'm trying to produce, and how I'm trying to produce, right? But today, with all these advanced predictive algorithms available, all I need to do is feed my historical data and input some of the manual intelligence that stays in the mind of my planners, right? So, and if I can do a combination of these and train my algorithms to derive a contextual capacity value for a particular product I'm going to produce on a particular day under a particular set of conditions, right? That is how a machine really behaves, right? Or the output of the machine really depends on, right? If I'm able to have this engine which is able to give a differential capacity value for every product I'm going to produce, or for every operation I'm going to do in a day, then it's probably going to unlock a certain hidden capacity that was never visible to even the factory manager or even to my the management, right? So this is capacity extension with zero investment. So I've not increased. I have not even increased the speed of my conveyor, but still my capacity has increased overnight. It's because that we are able to unlock efficiencies just by using dynamic values in place of static values, right? So again, we are talking about time varying parameters, right? So I may not get the same output from a machine on a Friday evening compared to a Monday morning. It could just be a function of my machine operator is wanting to leave home early, or they are there in the mood for a beer in the evening, right? So how do I determine time varying parameters? So again, we are just talking about one value called capacity. There are so many other hidden master data values. Your goods receipt processing times, goods issue processing time, your quality inspection time, your lead times, right? So anything that talks about a unit of time, right, definitely has variability. I think all of us will agree to that. And there's enough historical data with 50 years of ERP usage to be fed to our predictive algorithms, and with input from the most intelligent planner to consider dynamic constraints and parameters. I think we would be able to definitely improve the quality of the production plan. Again, this is not a I would say breaking news or something that the planning community has not known all along. It is just that the time was not ripe to make this time varying input readily available to my planning algorithms or the solvers themselves, right? And okay, so what would this engine do? So let's say we build this black box, and my most smartest planner has trained that black box, and I've given it access to my last 20 years of data. So now what will that do is basically it will identify patterns in your historical data, and then also learn from other inputs that need to be done. So again, history is not a representation of what to expect in the future, especially today. Therefore, the engine would not only rely on historical data, but also consider the human intelligence parameters, right? So however smart the planner is, he is probably using a set of rules and a combination of them to make a change to the plan, right? So that's what we train the model on, in addition to the historical data, right? And from this historical data and the planner intelligence that is assetized, if I can call it that, so we derive specific values, and these specific values are then going to be the input for my production plan engine, right? It could be an Excel file, it could be an advanced solver on the cloud, right? So the quality of my input improves. Of course, the quality of my output is going to definitely improve. And some of these parameters, like let's say manufacturing lead time at an operation level, may not be available today, right? We may only know the day when production was started and the day when production ended, right? So that should still be good enough information to go to the next level of accuracy in my dynamic input. But as we speak, a lot of factories are getting IoT enabled, right? So in the next few months or 12 to 18 months, we are going to have so much of operational data that's going to be available in addition to the historical aggregated data, maybe, right? And so it's not just it's not that IoT is a new concept, especially in process manufacturing and flow manufacturing processes, and your machines have already been sensor enabled for the last 30, 40, 50 years, right? So those industries, they already have granular operational level data to already leverage. But even other discrete manufacturing industries, which are on the evolutionary curve for sensor enablement of their critical machines, I think a few years from now, even them would have operational data, which can then further be improved to improve the quality of my production plan further. So a factory or an organization need not wait for the digital maturity in manufacturing to consider improving their production planning process, but it can also be a step process, right? You try to do the best with the data that you have, and then once the quality of data and the granularity of the data improves, you improve the quality of the input as well as an ongoing basis. So yeah, that could be a better approach rather than waiting for all my factories and all my machines to be sensor enabled. So that's about how I can leverage predictive intelligence to improve the quality of my prescriptive investments and solutions that I've already made. Now let's consider a specific example In this case, this happens to be a product that was built by our own team, and to improve again the quality of a production plan and mimic a planner's behavior and minimize the component of manual changes being made to the plans, right? So what is the problem statement? Like we've been discussing, it's about production planning being very prone to human bias and error, and it's difficult to analyze a plan. So even though a planner may have time, so it's difficult to analyze a plan that's spanning across, let's say, 5-6 assembly units, depending on availability of raw materials, depending on multiple other constraints. So any planner who tries to change a plan to optimize for one parameter is probably um, uh, uh, affecting the availability or optimality of other parameters, therefore making the overall plan suboptimal. So that is a core problem of manual intervention, right? So what is that we provided? We provided, or we built from scratch a solution that is a combination of a intuition and a heuristic engine. A heuristic engine is nothing but a simple rule-based engine, right? That can be coded in VBA in Excel or in any archaic coding language, right? So heuristic engine itself is not the differentiator. It's the intuition engine that is helping improve the overall quality and minimize manual intervention. So what was the value that we were able to deliver as part of this? We probably saved on average about 60% of the effort spent in plan preparation or rescheduling the production plan manually, right? And of course, 100% acceptance to constraints and very, very high level of reduction in manual intervention, right? So if we look at the high level solution architecture on what it would look like. So again, very basic block diagram. You're talking about a data feed layer. It could be your ERP system or your planning system. In this case, an SAP environment has been taken as an example, and that as an interface feeds the data to my data storage layer. So we are trying to absorb all the historical data available in your traditional systems to our planner bot solution. So, and of course, in addition to this, it's taking a lot of external data if that is relevant for this particular scenario. So that could be another layer that is feeding this ingestion engine. And post that, the most important thing, or the most differentiating aspect of production planning is what you see inside the ML engine. In this particular case, what it is trying to do, it's trying to do two things. One, project my safety stock requirement for the future at a SKU period factory level, right? Based on the historical accuracy of forecast for that period, right? So again, organizations do not want to work with static safety stocks, because safety stocks being built around supply chain variability itself is time varying, right? So why should I hold safety stock to handle my peak variability if I know what my variability is going to be reasonably accurately for that particular period? So that was the idea, to say, consider what the variability range of forecast is going to be for that period, and based on that, estimate what my safety stock should be, right? That's the first step. Second, identify what are the typical reasons for manual intervention of a planner, right? Probably he is considering additional capacity for a particular period and limited capacity for another period to really simplify a reason for intervention, right? So if my algorithm is able to see that every Tuesday he has considered 2 hours additionally available and modified the plan, and every Friday he has considered 1 hour less available, right? That is something my engine can learn from history and incorporate that in the available capacity itself, right? So again, working on these two predictive inputs to say what should be my dynamic safety stock for that particular period, for that combination, and what are the realistic inputs that I should consider for planning based on the insights that it has been able to derive from system plan to manual plan changes made in the past, right? Based on these, it's going to feed a heuristic engine, which is going to do the standard production planning process. The business rules could be unique, but the process is the same. Consider the inputs, consider the constraints, maximize demand fulfillment, right? So that's what this engine is doing, though we built it from scratch, and this is a completely self-sufficient engine in itself. It could be built anywhere, or I could plug my ML engine to one of your existing production planning solutions, right? So again, there's a simple UI layer that's built on top of it for users who want to access this directly. But if you want to continue to use the existing user interface that your planners are familiar with, that is definitely possible. In that case, you can just ignore that there is a simulation and a plan view option here. We will just plug in our engine to your solver, and then your planners continue to see the output where they used to see, right? Only thing is it's going to be far better in terms of quality, in terms of considering realistic inputs than it used to be previously, right? So again, we call this a planner bot because this was end-to-end automated, right from consuming data from the source systems to generating these time varying parameters and inputs, feeding the heuristic engine, and then making it available for simulation or to be fed into your consumption layer, right? So that's why we called it PlannerBot. And again, this is a live and working solution that was implemented in just about 10 to 12 weeks for one of the world's largest FMCGs, who could not solve the problem of automating or providing a technology for production planning for 10 years. And this was in one of their largest geographies, right? So multiple attempts were made to kind of fine tune the existing solution, implement enhancements. Different teams, even the product teams, were brought in to kind of customize it to handle the planner's requirements, to build that intelligence into the planning process, but it was not successful, right? And then a 10 to 12 week exercise done by a team of 3-member team solved that problem. It started as generating a plan for 4 weeks for a few products for one factory, and then based on the success of this, it became a multi-category, multi-factory solution, and it was even they are even contemplating moving it to other geographies, right? So that can be the power of a very simple solution that kind of leverages your existing data and tries to kind of bring that understanding, if I can call that, or marriage, to put it crudely, between your predictive and prescriptive engines, right? And so this might be a time for a logical break. If you have any questions around this or around the topics we have been discussing till now, we can take it now, Salesh.
Yeah, sure. Thank you, Ashok. You've blended predictive and prescriptive really well in the early part of your presentation. You almost could say got them married, right? What really hit me like a nail on the head is that the whole static dynamic thing that you were talking about, especially in terms of master data, when organizations have so many years of transactional data, and we still have only static inputs, and that's causing, like you said, 20% to 60% manual interventions, then it's a gold mine waiting to be mined. Without AI and ML, you probably only have a toothpick, but with AI ML, you have a dynamite, right? And a gold mine waiting to be explored. In terms of questions, I do have a couple of questions. Ashok, do you want an easy one or a difficult one?
Okay, difficult one. I think I'll route it to Anusha or Sid. I'll take a shot.
No. Okay.
Yeah.
I mean, I can't judge which is easy or difficult, but there's a question from Bharat. So it's a lengthy question, but the summary is that what Bharat is saying is where manual intervention is unavoidable, is a heuristic better than an optimizer, right? Because heuristic based plans are easier to understand and to some extent manually understandable. But Bharat feels that when you use an optimizer, there are quite some constraints and dependent plans that a human intervention cannot keep into account. So he's saying where it's unavoidable, absolutely, is a heuristic better than an optimizer.
Okay, I think our Dr. Anushya will be the first one to challenge that. Uh, right. So, but I understand where he's coming from, right? From a change management perspective, from a results interpretability perspective, and ability to enhance an existing algorithm, right? So, heuristics is always preferable compared to optimizer. But when your system gets so complex that rule-based approach to generating a production plan is probably not giving you the optimal plan, or is not able to consider, let's say, some dynamic inputs, like let's say least cost sourcing. Let's say I have 3 suppliers, right? So each supplier is not necessarily preferred. One is better in terms of quality, cheaper in terms of cost, right? So something like that. And let's say they themselves, their prices keep changing over a period of time based on the input costs, right? So what do I consume? What do I generate a production plan for, right? In a heuristic, I will probably follow a simple quota based or priority based generation of the purchase requisitions. But if some dynamic rule has to be considered, that is where optimizer comes in. And again, this is a separate conversation in itself. How do you make the choice of a planning solution, right? So do you go and go with the heuristic or an optimizer? So there are cases where both have fallen flat. Many cases optimizer implementations have failed, and I'm sure that's where Bharat is coming from. But there are also cases where optimizers have been quite successful, but primarily because the change management around the optimizer implementation was probably managed more efficiently and more effectively, and also because there was a real case for an optimizer there. There is no point plugging in an optimizer for a production planning solution just because I have a license for it, or because I have a citizen OR expert, right? So it needs to be really need based, because the complexity that it brings in terms of change management and training of my planners needs to be balanced against the benefit it really brings to me vis-a-vis a simple heuristic engine that can just follow step by step that my planner asks it to do, right? So yeah, that's a different conversation, but
Ashok,
yeah.
So time is 5 p.m. now.
Yeah.
I think we have 10 more minutes. I think we should really go forward and talk about the Uber
Sure.
problem, right?
Sure.
There's someone in the comments, anonymous, asking if clients will need this tool despite of them having SAP APO. I think definitely yes. Very much. We've all seen that, but in the interest of time, let's go forward.
Definitely. One line answer is yes, but the detailed answer would be you would need to study your need versus what APO or the existing system is able to support as of today. But in terms of the hidden value, be it APO or any other large enterprise solution, the hidden value to be unlocked from the concept that we have discussed still remains. Yeah. Now moving on to a more interesting problem. Right. So traditional fleet optimization versus Uber. Right. So let's take the case of a traditional fleet optimization. Let's say Sailesh is a business magnate who owns 500 trucks. Right. And he knows his market, he knows where his customers are, and there is enough demand, and he's able to run his business. But still, there is the concept of optimization, right? So especially if he's operating in a country like India, 500 or 5,000 trucks, where should he put these trucks, right? Where should they be positioned, right? What is the potential starting point for my next order, right? So I should plan my current trips based on the probability of getting a demand from the endpoint of my current trip, right? So that It doesn't happen. My trip goes to a remote place in Ludhiana and it's stuck there for 2 weeks without a return order, or I have to spend thousands of rupees just to move it to a location where there is an order, right? So again, if you consider a fleet optimization as a problem, what is my primary objective? And here I'm considering the case of a fleet owner, Sailesh, right? So what's my primary objective? To have the right vehicle at the right place, right? So I may have different type of trucks. To keep it really simple, I may have temperature control trucks and dry goods carrying truck, right? So now where do I put which kind of truck, right? Second, and the most important is SLA fulfillment, right? How do I fulfill the SLAs that I have committed to my customer in terms of turnaround time, in terms of turning up on time for loading, right? And all that, and vehicle utilization. So having the vehicle at the right place, is my vehicle utilized the right way? Am I using the full capacity of my truck for most of my trips, right? And the last, of course, is to minimize deadhead and dry run. This is unavoidable. You're not going to get return load from every trip, but you would have to drive without load from end of previous trip to the start of the next trip. But how do I optimize that? How do I minimize that, right? This could be the primary objective, and the constraints being what is the fleet size that I have, and what is the driver capacity or my driver availability, and the work hour constraints that I need to work with, vehicle capacity, of course, and a vehicle preference for the shipment itself. So does the customer need a dry or a cold temperature control truck? And what are the incompatibilities that I need to consider? I cannot move food and detergent together, even though it improves my utilization, right? And what are the time windows and appointments that I should respect? So these are components of a traditional fleet optimization problem. So any solver that is able to consider all these constraints. So we have experts in-house who can build these on Excel, and of course we have Dr. Anushya who can build a solution to handle the most complex traditional optimization constraints, right? Now then, what else is the problem? Why is the output of even the most advanced fleet optimizer not able to meet the requirements? One could be, I've tried to capture them under the other challenges. They are probably the biggest challenges. One is the variability in my loading unloading times, right? So I have considered standard lead times, just like goods receipt and goods issue for a OEM. Loading and unloading times is what is for fleet optimization, right? So how do I do my driver rostering? So how do I consider the optimal way to schedule my drivers, right? How do I make it easier for him to go to his hometown after the trip, right? How do I give him that rest that he deserves after every trip, right? Do I go for a 2-driver model, 1-driver model, right? So all those things. Minimize wait time between trips, right? So I don't want my truck to be standing idle. And what are the unscheduled stops or route adherence issues that have been affecting my SLA? And the last one is dynamic routing. So my truck, at least within city limits, is not going to be following the standard route that I have considered for my planning. So all these things are variable parameters, right? We have standardized them, and just like master data, we have made assumptions in the overall lead times, and then we have just packed them in for the optimizer, right? So going back to the same concept that we talked in production planning, if I can have an intelligent engine that is able to give me specific contextual values for each of these. If you go to this customer on a Friday morning on the 25th of a month, you will end up spending 25% more time for unloading. This is something that is probably visible in the patterns, right? So, and the patterns have a reason, and our ML algorithms can definitely pull out those reasons. So if I'm able to give these times, then I'm going to schedule my trips accordingly, set the right expectation with my customer for the current trip, and also commit accurately, more accurately for my next trip. So I'm going to consider my truck available for the next trip based on the completion of the current trip, right? If my whole scheduling of my current trip is wrong, right? So both my customer for my current trip and the potential customer for the next trip, both are going to be absolutely unhappy with me, right? So again, this is in a traditional fleet optimization problem. How can I improve it? The same concept of leveraging external drivers and your historical data to provide contextual inputs to the solver, thereby improving your quality of the trip plan that is generated. Now let's quickly move on. Spend a minute on the Uber problem. So though we discussed about a truck there, it need not be a truck. It could be a passenger bus. It could be a Tata Ace for last mile delivery or your Uber truck, right? So it's the same. Fleet of optimization problem is the same. Only difference is Uber probably owns hundreds of thousands of vehicles or has them at its disposal. Now, what is fundamentally different from a traditional fleet optimization long haul movement versus Uber? Some of it is quite clear. It is real-time predictive intelligence that is required for Uber. So Uber is probably the best example of predictive and prescriptive working hand in hand. How many of us book an Uber trip 2 days in advance? None of us, right? We probably book 5 minutes before we need the trip, and it actually turns up, right? So what could be happening? Not even in that 5 minutes. By the time you enter your source and destination, and you ask Uber to check for a vehicle, it probably takes that 30 seconds where you keep looking at the Uber graphics, right? But what's happening in the background is this predictive and prescriptive engines talking to each other, right? The predictive engine predicting where this customer wants to go. What is the probability of me getting a return trip from there? What is the probability of me getting other passengers interested if it's a Uber pool preference that you check? So the most obvious thing that comes in the form of output is the pricing, right? The predictive and prescriptive engines are working together, identifying the probability of making an overall profitable trip and then pricing it accordingly, right? Sometimes you may be surprised, the same source and destination, I get it for 1/3 the price, and sometimes it's 4 times the price. Surge pricing that all of us are aware of, and probably the most biggest complaint that we have with Uber or Ola, right? So this is what's happening. So the machine learning engine is doing all these in that 30-second interval, estimating potential demand, estimating the duration of the current trip, and looking at the route that you may have to take now, considering the real-time traffic, congestion, and every other parameter that will affect it, right? So based on these, it is then feeding it to an optimization engine, which is trying to optimize the vehicle to route allocation, the passenger to vehicle allocation, and of course the dynamic pricing that should happen. So this is probably the most advanced and realistic proof of concept that a real-time predictive and prescriptive interface can work, right? And it has been working globally, and that's why it's been such a huge success, right? So probably all of us might have been aware of this at a superficial level, but what's happening under those graphics is basically these two engines talking to each other and giving you that price that you're happy or totally angry with in that 15-second time. So I think we are almost at the end of it. I'll just take 10 seconds to talk about potential other applications, just for us to carry it with us. So now let me say I have built all these, right? So are we talking about only building intelligence to get dynamic inputs so that my planners or my planning algorithms are able to give better plans? Can I do something more with it? Of course, especially in today's scenario, once you have completed an optimization exercise, it has been done for a certain set of inputs, right? And all of us know that those inputs are quite dynamic, especially in today's scenario. So how you could leverage predictive intelligence better is to test out your optima, right? So whatever recommendations that have come in, you can use different scenarios of the demand itself or the drivers of demand, and then see how your optima holds under those scenarios. Based on this, you'll be able to confidently communicate to your management or your business leaders to say, what is the validity range for this optima? You can say, going back to the same fleet optimization problem, please put 200 of the 500 trucks in that industrial city in Ludhiana, right? Provided these parameters remain true. If these change, you may need to have a contingency to say 500 it becomes 400. The rest of the 100 I move to an industrial city in Odisha, maybe, right? So you are able to test out your optima based on different scenarios predicted by the same intelligent engine, right? So this is another application, post optimization to do advanced sensitivity analysis. So basic analysis, of course, all of us are doing, but this would be realistic sensitivity analysis, at least to where we are today. The last few seconds may be on other applications like computer vision and geo AI, for which we had a very very insightful session yesterday, is to see how can I identify business activity levels, right? Just from a camera within a store or from a satellite image, which is probably giving me real-time or close to real-time images of trucks entering a particular warehouse, right? Based on this, if I can have a proxy for business activity levels, that itself becomes an input for optimization of my resources, to plan my capacities, to plan positioning of my assets, right? So this is again a different line of study in data science maybe, but again using data science intelligence as a proxy to refine the quality of input to my optimization exercise, right? So that's another interesting example, and quite a few of them are being deployed as we speak. So that brings me to the end of our conversation. You have two real quotes, and these are not my quotes. I've pulled them out of the internet, both from eminent people. Contexts are different. One is in the context of computer programming, other in the context of someone writing a book, trying to become the next Shiv Khera of the world, right? So whichever you want to take it, want to consider it as your takeaway, it's up to you. And I'd like to probably end the session here and take some questions if we have the time for it. I'm really sorry we have short the time by 5 minutes. Sailesh, back to you.
So we don't have questions on this fleet optimization front, Ashok. But thank you for that session. These learnings are applicable to so many startups in the world today, be it an Uber versus Ola, or be it Intercity, Revigo versus Blackbuck, or be it Delivery versus Ecom Express, or be it an Intercity shuttle, right? Fleet optimization, right? Vehicle route allocation is so important. Thank you for those lessons. I think we have to close because we've overshot. I'd just like to mention that our in-house optimization expert, Dr. Anusuya Ghosh. Do follow her on LinkedIn. Do follow her work on LinkedIn. And yeah, that's thank you from us. Over to Nischay.